Everybody, my name is Dr. Bill Layman. I'm always so excited to share the things I'm working on here with LuxCreo, the direct print aligners. Today we're going to talk a little bit about, the review of dentistry and economics. How did I adopt an in-office 3D printing methodology? A little bit about me. I see a lot of familiar faces. Thank you so much for the audience and people showing up and coming in. Had a long journey. I started out at a military college in South Carolina. Then right after my college experience, I decided to go kind of play around in the woods of North Carolina for a few years and jumped out of airplanes for a little while, and then met some people. Luckily I have some friends here from school, MUSC in Charleston, and then Vanderbilt for orthodontics training. Started a private practice by myself in Clearwater, Florida. I really did want to go work for somebody, but entrepreneur, the word entrepreneur, I've always wondered what that meant. I really do think it's French for unemployable, so that might qualify, unfortunately. And so I ended up going back to school about 10 years later, getting a business degree here in Philadelphia at the Wharton School, and have had tremendous opportunities in this profession of orthodontics. My first opportunity working with LuxCreo was, I first met them at the Chicago AAO about 2 years ago. That meeting, the ability to see what they were doing in the ecosystem that they were doing it, was just so fascinating to me. I'm a little bit long in the tooth now, a little bit older, and the opportunity, the ability to get into something brand new, the ability to maybe start getting on those small waves that are going to start getting bigger in our profession was just a little too much for me to avoid. So I really enjoyed that type of thing. I've successfully treated a number of cases. This slide's a little old. We're probably up to about 100 by now. And when I say successfully treated, am I talking about class 2 extraction cases? No, I'm talking about all cases. Some of these are going to be simple. You're going to see some cases today that I've treated, and I'm excited to go through that whole process with you. We're going to talk about what are direct print aligners. I think a lot of you may know what that is, but I'm just going to kind of have a strong definition for that. What's the future of clear aligner therapy? What that looks like, a few patient cases, and I'm going to share with you my workflow. My workflow being, how do we get from a patient scan to treated case with this type of technology? What are direct print aligners? Direct print aligners are nothing more than smart plastic. That's all it is. We've been using dumb plastic for 30 years. Nothing against the plastic. It's not bad. It's just dumb. You have to make the models work. You have to make everything flow. You have to get it all figured out. And then you take this piece of plastic and you melt it onto something. That's okay. That's fine. But now you have the ability to build that plastic from scratch, which to me makes it a lot smarter. DCA is the resin that we use. DCA is the resin provided by LuxCreo. There are a few other competing resins out there, and in this space, the ability to have the molecular understanding, to have the molecule of resin that you're going to be able to print and use while moving these teeth is something that this company has, I wouldn't say perfected yet, but they're definitely well ahead of the game. They use this type of thing in many other industries, and so they have this cross-industry knowledge that gave me the confidence to try this out on my patients. Because I'm not in education, I have a private practice. When I work with a patient, when I'm doing something with a patient, I'm doing it with a paying customer. And I really want to make sure that it is working exactly the way I want it to work before I start doing that. You can see here in this video, it's showing a couple things about the 4D aligner, showing a couple things about how the resin itself gets created into it. Active memory, if you haven't seen some examples over here, active memory means that the resin itself, when submitted to heat or 100 degrees Celsius water, will go right back to its original form. So your patients come in, they take the aligner out of their pocket and hand it to you. you know that piece of plastic is deformed because it's warmed up a little bit. And when thermoform plastic gets heated up or warmed up, especially with me being in Florida, they leave that thing in a car in Florida. That tray is not the same tray that I gave them. These trays are. So there's a lot of functionality in this active memory that helps quite a bit. I just want to take a moment to kind of maybe zoom out a little bit. The evolution of aligner therapy, when I started thinking about what was happening here, everything that was going on, I wanted to really say, where are we in the life cycle of aligner therapy? So essentially we have an evolution. We've all seen things like this. If anybody here has done something like this, I can say I didn't do a lot of these, where I would actually cut the models out. I would then move the teeth sequentially and then make a thermoform on each, and I had clear aligners. This is what happened. We've all heard the story more than likely. If you haven't, it's a well-documented story. The person that invented the first aligner company went to his dentist, and the dentist moved the teeth in stone, made a couple of aligners, and the person that invented that company said, well, why can't you do my whole case like that? It's just not scalable. Well, now we all know that it was scalable using digital technology. But that helped us get to the point where now we have digital technology. We can actually create some sort of scan, three-dimensional capture of a PVS model or a PVS impression and turn it into something digital and make trays. The first 3 or 4 years, somebody here may know the actual answer to that, there really weren't any attachments on the trays because who wants bumps on their teeth? I'm doing aligner therapy. Why in the world are you going to stick something on my teeth? Well, that was probably the late 90s. Well, we realized that didn't work. We had to actually add some bumps on the teeth. You can see that. So aligner attachments, because we couldn't move teeth without attachments. We had to put little handles on the teeth because when we do a thermoform, we know that the gingival third of that thermoform plastic doesn't engage very well. Many speakers talk about that, and they're 100% correct, that you want to have your attachments a little closer to the incisal third so that the tray can actually engage it. And so now, those attachments, like let's say 2010, the G series, all those different things, once again, at the time, an amazing technology has helped move millions of patients' teeth. By no means am I saying this stuff is bad. It's an evolution. Just like every evolutionary concept, we're moving from one thing to the other. Then we moved to optimized attachments. Why did we go to optimized attachments? Because conventional attachments had drawbacks. And so when something has a drawback, as a profession, we dig into it and we try to find an improved way to do it. And so that's what we had here. Now, at a fully modified resin tray, now that we have smart plastic, are we able to finally get away from the adjustments to thermoform trays? The adjustments being adding all these bumps on the teeth to overcome the restrictions of one type of technology. Will this technology help us evolve, once again, away from some of the things that we had to do to make it work? Well, I think the answer is yes, and that's where we're going. What is the future of clear aligner therapy? Fully customized aligner trays. I don't think we're going to be wearing trays like this, but a fully customized, like motorcycle, car, things like that. The ability to create something that works for that patient's particular situation is what I feel like is where we're going to be in the future. So what will make this a reality? I've spoken to many of the doctors that ask me questions about this system. They call, we do Zoom calls, things like that. We're going to need research, and not necessarily research. I know we need university research, because I know as a private practitioner, when I hear the word research, I kind of cringe a little bit. I'm like, oh man, I don't want to do any research. I'm talking about clinical, let's dig in and try to figure this out a little more. This is a project that I'm working on right now, where I want to pressure test. I want to pressure test the concept that if I am able to use pressure points or negative attachments. On ULab, what happens when I put these glue pieces in there is it creates a negative in the model, and I'll show you that in a second. So if I can have an attachment on one side, and I started with the laterals because we all know laterals are such a hassle to deal with when it comes to moving teeth with aligners. Even the most compliant patients like Raj, the lateral still doesn't always go right. It still has some issues. And so I've got 15 cases I'm working on. I've got attachments placed on the upper right laterals, and I've got pressure points on the upper left. And so far, the teeth are moving great. I got a couple clinical cases I'll show on that in a few moments. There we go. Now, the concept of negative attachments or pressure points, I'm using both of those terms because I'm not sure which one is going to resonate better, so that's why I'm saying both of them. A negative attachment is nothing more than you can see here in this situation. When I'm able to make that negative in the model, I can see how now I've got a little pincer in the neck of the tooth of a lateral. I use a lateral because it's usually very difficult to hold on to. And so we have that little piece right there. You can see in the model. So when I print the model, this is what that looks like. That representation of that blue on the aligner software, the ULab aligner software, is an indentation. And you can see here on the actual tray itself what that looks like. Now, the question you may be asking yourself, is that long enough? Is that thick enough? Is it in the right position? I don't know. I know that in that position it's working right now, and that's why I ask anybody out there that has any curiosity in this, please come do it with me, because I want to learn this and I want to get better at this and I want to improve this. But so far, this position and this size is working really well. There's so much variance that we have. The ability to change, the ability for direct print aligners to have whatever thickness you want at a certain understanding, a certain resource constraint, to be able to change things on the tray itself is amazing. And at the same time, the ability to make so many changes is evil, because now we have so many options available to us that we do have to bring that down into position. Now, the biggest part for me was to understand that this exact same model that I had digitally made the direct print aligner from a thermoform standpoint, if you just do a suck down on that, there's really nothing there. So we can do pressure points, we can do all these things all day long, but if we're just doing a thermoform, you're not really getting that same, in my mind's eye, when I do a pressure point or a negative attachment, I think it's the same as using like a Hilliard's plier or something to put a little bump in there. It's not the same. I mean, unless you do like a really huge one on the digital. Whereas with the direct print, you have the ability to do that. So attachments versus the plastic engaging the teeth more effectively, that's the big point I'm looking at right now. And you can see the comparison in these two photographs here. Now, another concept that I'm starting to work on and hopefully understand is that the AAO speaks very clearly to a lot of the different constraints that we have, a lot of the issues that we have with moving teeth with aligners. And in this situation, we're looking at expansion. You can see on the bottom right of the screen the limitations, and what these percentages represent are, if you have a ClinCheck, because this study used Invisalign, if you have a ClinCheck and you move the teeth 1 millimeter expanded, on average you're only going to get 0.7 millimeters on the canine. That's what that percentage that's what that really means right there. And so the question is, if I'm able to change the plastic, if I'm able to adjust the plastic to give me the opportunity to improve the accuracy of my plan versus what actually happens, that's just good for everybody, right? We're not having to guess. I've always kind of told patients sometimes that with braces, I can put my hands on the steering wheel and we're driving. With a liner, sometimes it feels like I have two ropes holding onto the steering wheel and I'm trying to get down the road. I get there, but there's a little bit like this and that. So it's kind of funny. Some of the other day I was talking to him and they said that we were talking about playing golf, and he told me he plays military golf. And I'm like, what's military golf? He's like, left, right. And I thought that was kind of the same way with a liner sometimes. We're kind of trying to sneak up on the answer, things like that. So this is the next project I'm working on, the ability to change the lingual surface right there. One, will patients tolerate it? Two, will it actually predictably, if I take my superimposition on my initial models and my final models and I superimpose where I wanted it to be versus where it ended up, how close will that be? My goal is to get to 95+%. So if we can do that, then Now we've got the ability with this thickness right here to say, yes, please add the expansion thickness on the lingual so that your protocols are exactly where you want it to be, which works out well. You can kind of see it from all around. You can see the different thicknesses. Now, am I going to make it 1 millimeter? I don't know yet. I'm working through it. I'm working it out. Patients may not tolerate it. I may have to move it up. That is the beauty and the evil of this type of research, is that you have all kinds of options available to you, but it can be very fun if you want to get into that and start understanding it all. Patient cases. So this is like the diastema closures we talked about, a little space in between the teeth. And the concern with this case, the reason I did this type of case is because when you squeeze that diastema together, there's a concept called the disappearing lateral. I think it was either Jonathan or Moz put out some articles about that talked about when you squeeze on that lateral, the tooth can intrude. Pretty much any tooth like that with not a real height of contour like that can happen. And so usually we will put attachments on the facial of that tooth, of that lateral tooth, so that we don't lose the vertical. Now, am I moving the tooth vertical yet? Don't know yet. I'm not really working on the extrusion per se, but if I can stop the extrusion with those bumps, that's a proof of concept that I can likely extrude with them, and that's next. So we're working on that. So you can see how we set it up on ULab, how we intrude the teeth so that we have some overjet to actually retract and make it go. And there's the goal, is that, if anything, I think the left lateral probably did a better job holding its vertical than the right lateral. So that's, once again, I need proof of concept. Trust but verify. I love everything they're doing. I appreciate everything LuxCreo is doing and has done. I need to do it in my office and make sure that I'm really feeling it. Like I said before, these are paying patients. I'm not at a university. I'm not, this isn't in a lab. This is on people that came to me and said the words that kill me the most, the words that just hit me in the heart. Doc, I trust you. Ooh, man, those are, if you don't feel the weight of those words, you might want to reconsider what you're doing, because those words are very heavy, as they should be. This next patient had some crowded lower teeth. She was a starting law student. She really didn't want to mess around with too many things. I do have some attachments on some of these cases, but not on all of them. I still want to have some predictability in certain parts of the case, and predictability meaning something I've done a lot of that I know will work in a certain way. You can see a pretty typical case that a lot of us have. The fixed retainer had failed. The tooth started to move a little bit. So she was like, I really want to get this done. I actually did this case with the 4D aligner program. So one of the first cases I did with that, the program that LuxCreo has, where they'll actually make the trays for me. Because this was very early on. You can see the setup there. In hindsight, I really didn't even need that attachment on the canine, just because of some of the rotations. It got triggered and I didn't take it off. Because this was, once again, earlier on in the cases that I was treating. And so you go from there to there. And so she was happy. Of course, you can look at it and say, what about those extra 2 degrees? She was in law school. She was excited about it. She's like, I'm good. I'm done. Let's move on. Next case, crowding upper and lower. This is getting a little high mild. Once again, today I'm not going to show you cases that have teeth all over the place and show you how I did it. We're creating a symphony here. It's like, when you create an orchestra, you got to get your strings right, your horns right, your drums right. I'm still working on the small sections to make sure they're good. By next year, definitely, the orchestra should start coming together, which should be a lot of fun. So I'm showing you kind of some of the sampling of the different instruments today, because if we get that right, then everything else will be good. And so this is a little more of an upper and lower case, a little bit more going on, quite a few more attachments, but not as many in the front. That to me is the biggest thing. I can still throw some in the back. Patients usually tolerate that well, but trying to keep them off more of the front teeth is really great. And once again, this was something that, this is me being an orthodontist with all my idiosyncrasies and insecurities sitting in the office saying, this is how I'm going to set this case up, and this is where it ends up. But, having the ability to get the case and the patient happy where they want to be is great. Boy, that thing really jumps on us. Okay, once again, taking those pieces, going back to that symphony where we talk about, can we tip the teeth? Can we control torque? Can we extrude the teeth? Can we hold the teeth from extruding? All of these simple movements that we're working on, I thought this was an excellent case because it's so clear on what we need. She came from the periodontist, and at the periodontist, the root of the lower right one, I believe it was, is so far forward that they didn't really feel very comfortable grafting that tooth. And they were like, hey, Bill, can you move this tooth back in just so we can get a more predictable graft? And you can see it here. That's a little scary. My friend Brian is a perio ortho. He's nodding his head, which is great to hear, great to see. And what are we going to do with this? Well, to me, torquing teeth with aligners, that's definitely, to me, a little bit more on the scale of, all right, we need to pay more attention to this. We're not just rotating. We're not just playing around. We need to really take a hard look at this. And so I thought this would be a great opportunity to use a couple of our things. Now, do I need any attachments on this? No. What do I need to create torque on that tooth? What do I need to move any tooth? Coupling forces. I need some sort of forces that are going to have equal and opposite reactions to actually move something in space. And that's what I have here. So I have those little pressure points or negative attachments on the lingual and on the lower because they have that little smiley face, that little point, little trough that goes in there. And the ability to do that will create a little additional force because of the way it does it. And this is not something that's brand new. This is not, and I don't even want to pretend this is something that Bill Layman came up with. This is something we've been doing way back, even probably before Align back then, when you actually would do stuff in your office and just make little bumps on the trays themselves. But the ability to move that root lingually, to me, was proven very visually. It's not on a CT scan. It's not an angulation on a Ceph where I can kind of play with it a little bit. To me, this was very clear that it worked and that it happened. To the point where the periodontist actually watched this for about a month or two, thinking it might actually come back together. It didn't. They ended up doing a graft, which was smart, not smart, I don't know. I'm not a periodontist, but it worked out really well. I haven't gotten that picture from them. Maybe I'll get it one day, but I think we all know what a graft looks like. So the tooth had moved really well. I was happy with that. And so what has to happen? Sorry, God, this thing is quick. 3 things have to happen. I think this is important. 3 things have to happen for this to occur, for tooth movement to occur with aligners. Number 1, you got to get the mechanics right. If you don't do the mechanics right, then it's like putting a bracket on. If you put it wrong, the teeth goes all over the place. So you got to get the mechanics right. And at a certain point, there are so many lectures and so many courses out there to get the mechanics right. That's not too bad. What's the second thing that has to happen? The patient must wear the trays. So you have to have compliance. Because if I get all the mechanics right, but the patient doesn't wear it, this never happens. So that's another thing. But in this particular situation, what's the third thing? The third thing is the plastic must work. The plastic worked. So all 3 of those things have to happen, not necessarily in that order. They have to happen synonymously with each other so that this works. So to me, as I started treating these cases, am I setting it up right? Yes, I'm setting it up right. Are they wearing it? Well, yeah, they're wearing it. And we use a remote monitoring to prove that they're tracking well and that things are going well. And obviously, you don't even need remote monitoring to know that the tooth moved. They must have worn it. But if the plastic didn't work, this wouldn't work. Crowded lower teeth, looking at a case like that. This is a patient that was pre-restorative. They were going to have some implants done, and they just didn't really want to have crooked teeth the rest of their life. Because once they had an implant placed on that lower left anterior segment, those teeth were pretty much going to be crooked. It'd be better to do it beforehand. She was actually fantastic when it came to setting up her teeth. With the ULab software, I'm able to add a ponic right there really easily. Able to move the teeth really easily. Once again, because of the way the canine was positioned, I did put an attachment on it. Today, if I was doing the same case, I would not put an attachment on this case whatsoever. It just doesn't need it. Because I'd maybe probably put a little pressure point in some of those areas where the teeth are having to move and rotate. She was pretty excellent when it came to compliance. Once again, we got the mechanics right. Number 2, the plastic worked really, really well, and she wore it. she did not have a refinement. This is her case at the end. Now, could I do a refinement? Probably. I mean, I can always do a refinement. I think, I've talked to my team about this. I think the days in practice that scare me the most are debond days, because God, I always see something, So at a certain point with aligner therapy, are we treating the patient or are we treating our egos? For me, unfortunately, I keep going and going and going. That's why it's always hard for me to show pictures, because every time I show a picture, I'm like, yeah, I know, a little bit here, a little bit there, but maybe that's just the neurosis that we have and why we got this job. I'm not sure. This is the type of case I get quite a bit. Worn front teeth. I live in Clearwater, Florida. Call it God's waiting room, whatever you want to call it. And I get a lot of patients that have had worn teeth over a long period of time, and they're like, all right, doc, I'm getting close to retirement. I had a payout on my business, whatever it is. I want to get my front teeth looking awesome. They're like, well, I can't, because your teeth are completely worn down. They're hitting right on top of each other, and we really need some ortho to get you set up and to undo all of the damage that's happened over the years. And so I get a lot of those cases, and I don't like using aligners on those cases. Sometimes I use them on top, but I usually try to talk them into braces on the bottom. This particular patient had a little bit of an overbite. She had a space that had opened up because of her class 2 bite, and she had some overjet, so the front teeth kind of came forward. I'm sorry I thought about this the other day, I didn't take a picture with it open a little bit to show the wear, but if you look at the lower arch, most of you can probably tell there's some wear there that the patient wants to restore, and it's because of the contact on the uppers. She really asked me, can I please do aligners? Can I please do aligners? I'm like, look, Stephanie's our TC. I'm always like, look, we'll try the aligners. Sometimes I'm like, no, but sometimes like, let's try it out. If it doesn't work, then just tell me you'll let me do some braces to finish it up. And usually I can just do them on the bottom. Well, she did an excellent job. She opened up really nicely. She did a great job wearing everything. And the dentist was able to restore it. Now, like me, if you're looking at it, you're like, you're still with a class 2, you still have space right there. Yes. The patient just wanted to get the bite open. That's all she needed to do. We weren't going to dig in and fix all that other stuff. I get patients that are 71 coming in and needing this type of thing. They're not going to wear a carrier or a Herbst or anything like that to get their bite. They're pretty happy with where they are. But the ability to create that level of bite opening, to improve the overbite the way we did, with no attachments on this case, was really fascinating to me. Now, what's the mechanics behind that? The size of the teeth, the way they were, the ability to engage those interproximals and put that force level on the teeth. She had to wear it. My mechanics, I was a little nervous about this one. I wanted to do it without attachments. It worked beautifully, but the plastic had to work. And that's a question I get a lot. Does the plastic work? And boy, it's working really well. So we'll talk about my workflow for a little bit. You've probably seen, if you haven't, they've got some great demonstrations here on how a workflow works. I create my aligners in ULab. I go through and I can essentially set up the case the way I set it up. I can use the ULab augmented system, the UAssist, to set the case up for me, and then I can download from it. It's an easy platform. I can add, it's, that's a different lecture, but it's an easy platform to set up cases inside of. When I import to Fast Track, so now we're getting into more of the software side of LuxCreo. There's 2 programs inside LuxCreo that you're going to be using. One is called Lux Design. That's where you actually design the trays, create the shells, get it ready. And then there's something called LuxFlow. LuxFlow is similar to Rayware or Form, whatever it is, that actually connects you to the printer itself. Every 3D printer has their own proprietary software, and so that's what LuxFlow is. But Lux Design is where you get to add that magic and create the trays and create everything that we're going to be creating in the future with the thickness and multi-thickness and things of that nature. And this is the LuxFlow process. This is the Lux. So the Lux Design, essentially, you download, you bring in the models, you hit the button generate, and when you hit generate, it creates all the trays for you, and then it's ready to go. And then you export. And here's what you're exporting to. You're exporting to this software itself. And you can see how the trays are set up. Now, Direct print aligner trays must have the ability to, well, I don't want to say it. You can see here how the supports for the 3D printing is right on the edge of the tray. If you see anybody out there that's doing direct print where the attachments are not right on the edge of the tray, walk away, because you're going to spend forever trying to get that smooth polished surface back to what you want. There are even splints. I mean, the splints that they make, there's only about this much on the very front where they actually have the screws or have the actual attachments for the 3D printing, and that saves so much time. Like, the engineers didn't take a lot of time to make it work, but it's going to take you a lot of time to polish all that off. They've done the hard work putting all the supports right along that edge of that file so that you can just pop it off and polish, which is the part that really helps us out quite a bit. And then you have a one-click process. You go straight from LuxCreo, straight to the printer. It takes, on average, I can usually get about 12, and I have to be at the 70-degree support. At 70 degrees, you have two options, 45 and 70. And really, there's no difference in real quality on that. The difference is time. Just like everything in 3D printing, it's the time to print per layer times the number of layers. That's 3D printing. Everybody asks, how long does it take? You can get the math on that pretty fast. It's pretty easy. And then, so I get about 12 trays on there per, which is really good. Takes about 60 to 70 minutes per pop. The wash process, they have a machine. You drop them in there. What you want to make sure, there's a couple little things. You want to make sure that intaglio surface, that surface of the tray that faces the tooth is down. Because that's the thing, is with 3D models, everything just drips off the side. With trays, they actually hang upside down, so when it comes out of the resin tank, there's still resin in the incisal edge. So you want to make sure you get that upside down so all that washes out. Because if you leave it upside down and you don't ever get that resin out and you go to the cure process, that tray won't fit. So very important. I mean, the wash cycle does a good job cleaning everything out, but having it that way is going to help much more. And then there's the LuxCreo Oven Pro, or Pro Oven, or as we like to affectionately call it, the air fryer. So works out really well. Just easy to talk about, just 10 minutes. And that's a simple process. It just goes straight from the wash straight into that, and then it goes straight into the cure. The cure is like maybe 20 minutes when you're using that. So people ask me sometimes, what's the post-processing like on these trays? And the post-processing is very easy when you're going that way. And this is it, the whole essentially workflow and about how much time it takes for each board of it. You know, just clicking off a little bit, pop the trays off, use a little sandpaper wheel here to actually kind of clean everything off, and it just turned off. What'd I do, Ethan? Oh, never mind, got it. Still excitement. All right. So aligner creation flow, when you're comparing a thermoform process to a direct print process, you can see the differences right here. You get rid of the processing the model, you get rid of the cutting out the tray from the model, you get rid of removing the model from the tray resin itself. Like, it tremendously reduces the amount of time. I go from about 9.5 minutes with a thermoform tray down to about 6 minutes and 20 seconds, which is a huge throughput improvement in our office. So if your assistant, if your lab tech, whoever it is, if it takes them 1/3 of the time less to do that in office, you can now make 1/3 of the more trays. Or that assistant that isn't seeing patients from 1 to 2 after lunch because they're working lab stuff, now they're back in the clinic. You want to open up your chair time as much as possible, because your economic yield on chair time should be dramatically higher than having to deal with this. But we still also have those patients that need the trays in a day or two. So this process has helped us quite a bit, remove some of the barriers we had in making that happen. And these are some of the costs that we look at. You can see how the costs are broken down. You can see where the costs are different. Material costs, one of the biggest ones for me right here is using the actual Zendura plastic, which is a little more expensive. And so this breakdown, there's some webinars out there, I'm sure ULab has them, things like that, where I do a much deeper dive. Seminar on orthodontics, Dr. Kazravi, Senna, and I We did an article that talks about how to break down all these costs. These costs are my costs. Yours may be a little different. You may be paying people a little bit more, which has something more in the labor. You may have different discounts on software. You may have different discounts on your resin, your models. But this just gives you a guide on what I feel like the most important cost drivers are when you're making this decision on what you're going to do and how you're going to save money. To give you an idea, I have direct print thermoform. If you are ordering from another company, you're probably paying about $30 to $40 per tray. So that's some of the understandings that you want to see, is if you're going to do something in-house, it's a make-buy decision. Am I going to make them for here, or am I going to buy them over here? There really is no right answer. It just depends on what you want to accomplish with that information. That's the goal that we're looking for here. Attachment templates. I still print a model for my attachment templates for two reasons. One, it's a composite resin. If you put composite in a composite resin, it's going to stick. And it's, we can use baking, we can use vegetable oil, we can use all these bio-friendly things, or I can just keep doing research and try to get rid of attachments. So it's almost like if I keep making these models and I get annoyed about having to make these models still and interrupt our flow, maybe I'll get more excited about getting rid of the attachments and it'll motivate me. It's like signing up for a 5K. Maybe I should go out and jog tonight. But if I don't sign up for one, I'm not going out jogging. One of my favorite stories is my friend in Harrisburg, Pennsylvania. His wife would never let him get a snowblower because she knew as soon as he bought a snowblower, they're never leaving Pennsylvania. Now they live in Florida, so her job worked. It worked out beautifully. She did a good job with that. Waste. Let's talk about waste. Look at all this stuff. You have all these, there's probably a reef off of Costa Rica somewhere. There have to be, right? Millions and millions and millions of models went somewhere. The plastic itself, there's some waste on that. This is it. This is what gets printed. And so you can see the difference in the weight that happens right there. So you can see the reduction in the amount of trash by doing this process. Whether you care about that or not, that's still a real impact that's happening. All right, so some of our takeaways. Active memory material enables thermal rejuvenation. What I mean by that is, if you put these trays in 100 degrees Celsius water, that tray goes right back to within 0.2% of the original tray you gave them the day you delivered the trays. So no matter how much they deform it, how many times they put it in their pocket, how many times they leave it in the car and heat and stuff, that tray is now exactly what we did. And all that reduces any refinements in the future because you've eliminated that tray issue. Right there, direct print aligners provide superior tooth and attachment conformity compared to thermoform aligners. What that means is the thermoform aligner can't really get all the way up to the gingival margin because of just the way it's produced. It's not its fault. It doesn't mean it's bad. It's just a restriction that we can overcome by building the tray from scratch all the way up. The entire workflow can take under 7 minutes of actual labor time. That's about a 33% reduction in what it would take us in thermoform, which in our office is a big deal. We go from a yield of 70 trays a week to almost 90-some trays a week. And so that's a whole separate conversation too. Production process produces a lot of waste. That's fantastic. Come on in, the water feels great. I'm looking for anybody that's interested in helping out with this, helping me. I've got all these little studies I'm working on. They're nothing. The things that I'm working on mean nothing unless people can reproduce it. If somebody can't reproduce it, I got to figure out what happened and understand why. But if people can reproduce it, I think we're really on to something. We're on to the next wave that could be a lot of fun. So thank you.